Alright, so we're going to start with just the general function f of x. We're going to apply these transformations right here in the order indicated, and we'll look at what we have in the end. So I'll scroll down, make a little more room here. So, alright, let's start with f of x. Okay, the first thing I'm going to do is up 7. So all I've got to do is take my function, and I'm going to add 7 to it. So up 7, I'll check you off. I'm just going to put a plus 7. Now we've got reflect over the y-axis. And anytime we reflect over the y-axis, the notes that we've come up with is we have said replace x with negative x. So we've also said, replace all instances of x with negative x. So I'm going to have some redundant parentheses here. So those two were initially there. And I'm going to replace this x right here. I'm going to put a new set of parentheses. And I replaced x with negative x. So if you like, at this step, look at it. Notice you have a redundant set of parentheses, and you don't need one. So you can rewrite it.
Mike McCracken to the base.
So you can rewrite it f of negative x plus 7. Now when we reflect over the x-axis, that's the next step, we're going to multiply our entire function. Multiply function by negative 1. So our current function is this one right here. So I'm going to put parentheses around that and a negative 1 on the outside. Negative 1 times f of negative x plus 7. So we have just reflected across the x-axis, and now we're sitting right here. Okay, left 1 is the next step, and we've said replace x with x plus 1. So if you look at what I've got in green there, I'm going to move it left 1. So wherever there's x, I need to replace it with x plus 1. So kind of recopying the green, f, a minus, okay, there's an x right there. So where there was an x in parentheses, I'm going to put in x plus 1. Okay, so there used to be an x right here, right? So now instead of x, I have x plus 1. And notice when I substituted it in, I put the parentheses around it just to show you that the minus right here, right, that's going to get applied to my entire x. So I'm now going to apply that to the entire x plus 1. So, if you want, you can clean that up. Let's look at parentheses. Do I have more than I need? I think as we look at this, we don't have, a set of parentheses we can necessarily get rid of. These two parentheses are here, the red ones, to show that the minus gets applied through. These ones that I'm checking off with the purple, those are there to show what's going into function f. And then these red ones, this one and this one, those parentheses are there to show that the minus 1 gets multiplied by that entire quantity. So the last step is a vertical stretch by 3. So we still need to do number 5. So vertical stretch by 3.
Meeting's at 3:45, right? At the meeting.
Vertical stretch by 3 is we're going to take everything we've got, we're going to take our entire function, and we're going to multiply it by 3. So 3 times the whole thing. Okay, so that whole thing is sitting right here. I'm just going to plug it in. Copy it and paste it. Now, I could simplify that a little. I could certainly simplify that, or you could, right now, you could leave that. The only thing you could do, if you look at kind of the terms we have here, inside we have this, we've got this piece here, and you've got the plus 7. So you could certainly distribute this minus 1 to each of those yellow pieces. Or if you'd like, you could multiply the 3 by negative 1 and clean this up a little. So let's say you did the 3 by negative 1. That would leave you with negative 3 parenthesis f of negative x plus 1 plus 7. And there you go. That's our new function. So we could call it g of x if we want. So if I asked you, how do g of x and f of x compare? You'd say, well, you can produce the graph of g of x if you move the graph of f of x up 7, then reflect it over the y-axis, then reflect it over the x-axis, then move it left 1, then vertically stretch it by 3. So that would sit you right with this one in yellow. So good job. That was a lengthy one. That was tough, but nicely done.